Oh, that age-old conversation that you never wanted to have with your AP Chem instructor. Today we're going to talk about alcohol. I know, right? To be fair, I'm not going to touch the socioeconomic or biological aspects of alcohol. I'm truly just going to teach you how to name them and how to draw them. We're looking at kind of our alcohol groups. We know, fundamentally speaking, from a biological standpoint, these have very specific effects that they start to have in terms of reactions, biochemically speaking. And so we need to be able to identify them and to write them. These are an organic class of compounds. Alcohol all being important here. The functional group we're looking for is that hydroxyl group, or the OH group, being attached. So here I've just got a base chain, carbon chain in kind of a semi-skeletal form. Semi-structural form. I don't have the hydrogens on here just to make it easier for us to start to look at an example here. But we could go ahead and say 1, 2, 3, 4, 5 carbons. Our base name is going to be pent. And so I'm going to go ahead and make an alcohol. I'm going to go ahead and attach, coming off of this last carbon, an OH group. I start by identifying my longest chain. I know it's going to be a 5-carbon chain, and now I've got an OH group coming off of here. That tells me it's an alcohol, OL, just like we saw with alkenes and alkynes. That ending of the base functional tells us the ending of our compounds. This would be pentanol, pentanol. We just changed the ending to indicate the functional group that we're looking at. This is an alcohol, ends in OL on the naming. So we do have to show where that hydroxyl group or that alcohol group is located. If we were going to number this, we could go 1, 2, 3, 4, 5, but then it would be 5 pentanol. Why not number it 1, 2, 3, 4, 5? So this would just be 1 pentanol, the 1 telling us exactly where on this carbon chain that hydroxyl or OH group is located. If instead of putting it on that last carbon, I put it, I don't know, here in the middle, why not? For sake of argument, this is still a pentanol. It is still a 5-carbon chain with 1 hydroxyl or alcohol group. Still a pentanol, but that hydroxyl group or alcohol group is in a different spot. It's on 1, 2, 3, 1, 2, 3. Doesn't matter which way we go. This is 3 pentanol for this structure here. And so again, same rules as before. Number it, show us exactly where it is, put it right in front of the name so we know exactly where it's at. Let's look at a little more involved example. Let's do 1, 2 dichloro. Let's do 4 octanol. Sure, why not? Sure, why not? We got 1, 2 dichloro-4-octanol. I'm going to go ahead and do the structural just because it's less carbons and hydrogens to write. You can write whichever form makes more sense to you. I'm just showing you the kind of the shorthand version because this is what's probably going to be fastest for us. Octa means it's an 8-carbon chain. 1, 2, 3, 4, 5, 6, 7, 8. Double check. 1, 2, 3, 4, 5, 6, 7, 8. Okie dokie. I'm going to call this 1. I said this was 2, so I've got 1 chlorine coming off here. I got another chlorine coming off here. And then I've got 1, 2, 3, and 4. 4-octanol. Boop. Our hydroxyl group coming off on that 4-carbon. And so here would be our skeletal structural formula for 1, 2 dichloro-4-octanol. Nice way to kind of start to think about how we start to name our alcohols. Cool. Another example for you. Let's do 1 bromo. Oh, sorry, that's a bad example. Let's do 3 bromo. And let's do 1 cyclopentanol. Sorry. We've got 3 bromo, 1 cyclopentanol. Pent meaning 5, cyclo meaning it's a circle. So that would be your kind of house conformation. Sorry, my house is kind of upside down. 1, 2, 3, 4, 5. We can assign 1 spot wherever we want. I'm going to put it right here at the top. So pentanol, that means my OH is coming off here. I'm going to go 1, 2, 3 coming around this way, and then have my bromo group coming off on the 3 position. If you'd gone the other way, 1, 2, 3, theoretically, and put your bromine over here, it's actually the same molecule. It's just been kind of rotated in 3-dimensional space in terms of how we start to write and draw our cycloalcohols. Cool. I don't know, one more? Sure, why not? Sure, why not? Let's do and bop, and bop, and we'll put an OH right there, just to really make this example count. Always start by finding your longest chain if you're going from a structure back to the name. Looks like I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 if I count that way. If I go 1, 2, 3, 4, 5, 6, 7, 8, looks like 9 is my longest. This would be a non-ane. Non-ane because there's no double bonds or triple bonds. Ane is a straight chain alkane. Oh, but it's not. Oh, we got a functional group. The important one here would be that OH. So this would be non-enol. I know. Non-enol. So we got a non-enol. Where is that non-enol? Well, it's on the 1, 2, 3 carbon. So this would be 3 non-enol. So 1, 2, 3, 4, 5, 6. I'm pretty sure that's going to be shortest because if we come from over here, all those numbers are going to be higher. So we got 3 non-enol. We've got a 6 and a 5. So we got a 5, 6 dimethyl. So we got, this would be a CH3 group. This would be a CH3 group. Then on the 4 position, we've got a 1, 2 carbon chain. This would be an ethyl. An ethyl group coming off on there. Cool. Alphabetically speaking, E comes before M. The di is just kind of it's not the base name. It's just telling us how many of them we got. We got 2 of them. So the E comes before the M. So this would be 4 ethyl, 5, 6 dimethyl, 3 nonenol for the alcohol name based on the structure that's been provided here. Cool. Alcohols, a couple different ways we can start to write them and look at them. But this would be how we would go about naming and drawing those alcohol groups.